This presentation is about recovering deleted FAT files. It is intended for the course CGS 5131 at the University of Central Florida. My name is Rick Lineker. So let's go through the sequence of events when the operating system creates files on a FAT device. The first thing that happens is the operating system creates a directory entry. This includes all relevant information, and below you can see the data structure for a FAT directory entry. 11 bytes for the file name, the attributes which indicate things such as hidden or system or archived, a reserve byte, and then we have the dates and times. Creation date and time comes first. It's 1 byte and 2 words. Access date, a single word. Now the start cluster high and start cluster low are actually separated. They're both words, but together they make a D word. This is kind of a throwback to FAT16. Then you see 2 words for the modified time and the modified date. Finally, a file size D word lets you know what the size of the file is. So, to recap, the first thing that happens when the operating system creates a file on a FAT device is to create the directory entry. The next thing it does is it has to adjust the FATs. Okay, and since they're mirrored, it's going to do the exact same thing to both. So an entry is made in the FAT matching the cluster location in the directory entry. So the directory entry has a starting cluster, and then the FAT entry corresponding to that starting cluster is filled in with values. Now, it's potentially might go past that one. Potentially it might go past that single cluster entry. In fact, the example file we're going to use is going to take up 2 clusters. So the first cluster always points to the next cluster. So for our example, the second chain in the cluster will indicate end of file. Finally, the last thing that happens is that the data is written into the data area of the disk. Okay, so here's the subdirectory, the root directory actually, and declaration.txt, doi.txt, main menu BMP, mountain.jpg, and so forth. And so this basically shows you all of the entries in the root directory. Okay, the next thing we're going to do is take a look at FAT1. Okay, so here we've got a number of these entries filled in, and they're all small values because this is early in the disk. Okay, you'll notice that this value is a D word, but you don't even need a D word since the actual value is 67 hex. So it'll be a while before these values get large enough to be 2. Okay, so here we can see that the values are large enough to need 2 bytes or a word. Okay, and let's just take a look and see where the FAT entries end. Okay, you scroll down and find where they end, and then I'm going to make a note of where they end. Okay, we still have entries. Okay, so here we have zeros, and whatever was the last file in here is set to end of file. So now I'm going to make a note on a piece of paper. CEC34 is where the first entry is 0. Okay. So good. Okay, let's go ahead and close this down. Close down WinHex. Now let's go on out here and copy a poem out there to the root directory of that. Alrighty. So now we've got that on the disk. And let's go ahead and run WinHex again. Open disk, and we definitely need to take a new snapshot as we've added. So the first thing is that WinHex is showing us we have something called poem.txt, and when we single click on it, it shows its contents in the data area. Okay, but now let's go ahead and take a look at the root directory. Let's scroll on down, and now we have poem.txt. So remember, the first thing that the operating system is going to do is to add the directory entry. Now let's take a look at FAT1. And I'm going to snip this just a little bit. I'm going to sort of scroll to where I was. Let's see. Okay, this was the old end of file marker. Now we've got, this was a 0, now it's filled in. And it's not actually an end of file because this, so what that's doing is that's indicating the next cluster in the map. Now the next cluster in the map happens to be right here, and that indicates end of file. Okay, so we shall close WinHex, and let's just make sure we're able to get a regular directory. Let's see, that's the J drive. Okay, and everything looks good. Poem.txt is out there. That's a Longfellow poem, one of my favorites. Okay, and from the command prompt, we should be able to do dir j and see poem.txt. So everything checks out as far as it being correctly copied to the disk. So now what we're going to do is we're going to mess that up and delete it. So let's say del j poem.txt dir j. See if it's there. Okay, now it's gone. We want to be really careful here. From this point on, we don't want to write anything to that USB stick. We just want to make sure that we can go in there now and take a look at it with WinHex, having not altered the disk after the delete. Okay. Let's open that disk. For sure, we're going to have to take a new snapshot. Okay, notice, funny, poem.txt, you still see it, but it says question as the first character. It's actually not really a question, as we'll see in the root directory. Question mark is an ASCII character. It's actually going to be E5 is the first character, but WinHex just puts a question mark there, so you know there's a question. So in order to undelete this, there are a couple of things we've got to do. The first thing we've got to do is realize that the data is still out there. So we don't need to do anything in the data area. The data is still there and nothing is required. The only exception to that would be if we had overwritten this with anything then that data area, the data from this file, may have been overwritten and unrecoverable. So the data area is good, we're good to go. But the two things we need to do is that we need to go ahead and change this back to poem, and that alone indicates that the file is no longer deleted. However, what's going to happen is it's not in the FAT. So what we have to do is open the FAT and manually, so let's go through here and manually edit the FAT. Okay, and I had written down the offset. So okay, so here's that end of file marker that we had. So that's one FAT. Now we've got to take care of the other FAT. Okay, and I didn't write down the offset for this, so I'm just going to have to kind of manually seek through there until I get to the end. Okay, so we'll put that same information here. Save that. So now let's go ahead and close this out and reopen that disk, taking a new snapshot. Now notice that poem.txt is there as poem.txt, not question OEM.txt. Of course, it's still the same in the data area. Okay, so let's take a look at the FAT and make sure we're good there. Okay, almost there. Okay, notice this was the old end of marker that we noted, and now our new data is there. Okay, so everything looks good. So I'm going to go ahead and close WinX, and let's go back to our folder and do a refresh and just make sure we're okay. Can I double click here? There we go. So there I've got the FAT file back, recovered, undeleted, and from the command prompt it's also undeleted. So there we just manually undeleted or unerased a file from a FAT system. So there's one more detail I want to take a look at. And let's take a look at the root directory to poem.txt. Now, it's the root directory entry starts here, and it's 32 bytes long. So it's this line, it's those two lines, okay? This is the file size right here. This is starting cluster low. Creation date, actually it's creation time, and then creation date. And then this is the cluster word hot, and this is the starting cluster high. So that's how you can find out what entry you need to put back into the FAT so you can recover, so that you can recover a file. Another thing you could do is go to Poem and find out the offset here. You can actually do some math to figure out what the starting cluster is from there. It's not nearly as easy as just going to the directory entry. So one final thing, you may have noticed that what I typed in was actually 0E, 0A, which is one more than this. So why would I type in 0E, 0A when it starts at 0D, 0A? Well, because 0E, 0A indicates the next cluster, not the cluster where we start. Remember, we put this into the starting cluster fat entry, but the number we put in there is the next cluster in the map. Okay, so recovering a deleted fat file. First, or my first step, is always to go to the directory in WinHex, or you could also use another program such as Autopsy. Really, any disk editor will do it for you. Then you want to change the first letter of whatever the file is that has been deleted from E5, which is the indicator to the operating system that's been deleted, and then change that to something that makes sense. You may or may not know what it's supposed to be, but even if you don't know, you have to change it to something that makes sense. Second, you need to get the starting cluster from the directory, remembering that the starting cluster is not what you're going to put into the fat, it's how you find the starting fat entry. Third, you're going to need to edit both fats. And lastly, make sure that you know how many clusters the file takes up. That's because you're going to have to recreate the fat chain and go next, next, next until you get to the end of